Welcome to Module 1, Lesson 4, the empty set. Today, we're going to explore one of the most fascinating concepts in set theory. Let's start with a quick recap of subsets. Remember, B is a subset of A if every element of B is also in A. This is what we see here in our Venn diagram. B sits completely inside A. Now, here's an interesting question. Can we have a set with nothing in it? Think about it like this. We have a box with toys in it. It's clearly a box containing objects. But what about an empty box? It has nothing inside, but it's still a box, right? The empty set is exactly that, a set that contains no elements. We can write it in two ways. First, using empty braces like this. Or we can use this special symbol, phi. Both notations mean the same thing, a set with absolutely nothing in it. Now, this is the most important property of the empty set. The empty set is a subset of every set A. That means no matter what set A is, the empty set is always a subset of it. Let's see this in action. Watch as the empty set fits into the natural numbers, the integers, and the real numbers. In fact, it's a subset of every single set that exists. But why is this true? Let's think about what it means for B to be a subset of A. It means every element of B must also be in A. So, to prove the empty set isn't a subset of A, we'd need to find an element in the empty set that's not in A. But here's the catch. The empty set has no elements. Therefore, we can never find a counterexample. The statement must be true. This is what mathematicians call vacuously true. It's true because there's nothing to contradict it. Let's summarize what we've learned today. Definition: the empty set is a set with no elements. Notation: we can write it as empty braces or using the empty set symbol phi. Key property: the empty set is a subset of every set A. This might seem strange at first, but it's a fundamental concept in mathematics. Next time, we'll explore supersets and see the other side of this relationship.